Hello everyone, this is Uday Kumar working as an assistant professor of physics in Dr. B.R.R. Government College at Chella. As you already know, we are dealing the chapter digital electronics. We will try to continue the remaining topics of this chapter in today's video lesson. Okay, so these are the topics that we are going to deal today. So in today's video, we try to understand what is hexadecimal number system, and we try to convert a hexadecimal number into decimal and vice versa. That means we also try to convert a decimal number into hexadecimal, and similarly we also try to convert the hexadecimal number into binary and a binary number into hexadecimal. Okay, so these are the topics that we are going to deal today. Okay, so now we just so this is hexadecimal number system. So let us try to understand what is hexadecimal number system. So the word hexadecimal means 16. Okay, we already tried to know little bit about hexadecimal number in the introduction classes of this chapter. Anyway, we try to understand it in detail now. Okay, so the word hexadecimal means 16. So you try to understand this one. So the word hexadecimal means 16. Okay, so it means that this system consists 16 basic digits. So that is what you have to understand. Okay, so this system consists 16 basic digits. Okay, basic symbols. So that is what you have to understand here. So since this hexadecimal number system consists 16 basic digits, we say that its base is 16. Its base is 16, and the 16 basic digits that this hexadecimal number system consists are from 0 to F. Okay, so that means the hexadecimal number system consists 16 basic digits which starts from 0, and remember, so it consists 0 from 0. You keep on counting 0 1 2 3 4 5 6 7 8 9. So that means up to 9 you are familiar, right? And after 9 in decimal number system we used to get 10, right? But instead of 10, now this hexadecimal number system will have A. Okay, and after A it will have B, and after B it will have C, D, E and F and so on. Okay, and that means after F it gets stopped. So these are the basic symbols that the hexadecimal number system consists. Okay, so you try to remember these basic symbols. So that means in this number system the basic symbols are 16, which starts from 0 and ends at F, and after F you can write the other numbers of this hexadecimal number system by using the same logic that we try to understand while writing the decimal number system or binary number system and so on. By using the same logic you can write all the numbers up to infinity. You can write, if you have that much patience, you can write up to infinite in the sense you can write 100, 200, 300 and so on in terms of hexadecimal number system. Anyway, so this is the table which gives the equivalent decimal numbers and hexadecimal numbers. Okay, so for example in decimal you know how to write the decimal numbers, right? So it starts from 0 1 2 3 4 5 6 7 8 9. After 9 what do you get? You get 10, right? How you got this 10 you already know, because from 0 to 9 these are the combinations of 0, and after 9 is finished you write the combinations of 1, which we can write it as 1 0 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8 1 9 and it continues. Okay, so from 10 to 19 these are the combinations of 1, and from 20 to 29 these are the combinations of 2, and from 30 to 39 of course in this table we have written only up to 33. So if you can continue, you can write up to 1000, 2000, lakhs of numbers, right? You have to follow the same logic. Okay, so initially we have written uh, the combinations of 0 from 0 to 9. Okay, so these are the possible combinations of 0, 0, 0, 0, 1, 0, 2, and so on. It continues up to 0, 9. After that, from 10 to 19, this becomes the combination of 1, and from 20 to 29 becomes the combinations of 2. So these are the combinations of 2, these are the combinations of 1, and so on. This is how we write decimal numbers. We already studied them. The same logic can be used even here to write the hexadecimal numbers from 0 to any number that you want. Okay, so now as you already know, the hexadecimal number system consists of basic symbols of 0 to F, right? 0 to F. Okay, so now how to write the equivalent hexadecimal number system with respect to decimal, that you can understand in this table itself, right? For example, in decimal number system, 0 is nothing but 0 in case of hexadecimal. Okay, anyway, let us first start with the 0. Okay, so the first number that we get in hexadecimal number system is 0, and hence you have to write all the possible combinations of zeros first of all. So if I do so, what are the numbers that I get? You just check it. This is the first number of hexadecimal number system, and the possible combinations that you get with 0 are 0, 0. This is the first number I get. Then next 0, 1. Then next 0, 2. Then next 0, 3. And the next one will be 0, 4. Next one is 0, 5. Next one is 0, 6. Next one is 0, 7. Next one is 0, 8. And the next one is 0, 9. And remember, in this case you will not be having 10, 1, 0. It will not be there. So that means after 0, 9, what is the digit that we have? We have A, right? So that means you get 0, A. So that you have to understand it. So now what you get? You get 0, A now. After 9 you will be having 0, A. And the next is 0, B. And the next is 0, C. And the next is 0, D. And the next is 0, E. And the final combination that you get with 0 is 0, F. Anyway, the 0 which is written before 0, 1, 2, 3 and all, that means it will not be having any value, right? And hence you can just forget about all the zeros that you have written over here. And hence this becomes, so whatever the digits that I have written in this table, the same numbers you are going to get here. So you can check it. You get 3, you get 4, you get 5, 6, next 7, 8, 9. In place of 10, remember this is 10, right? In place of 10, in case of hexadecimal number system, you will have A. And in place of 11, you will be having B. In place of 12, you will be having C. And in place of 13, you will be having D. In place of 14, you will be having E. And in place of 15, you will be having F. So this is what you have to understand. Anyway, so these are the digits, are the numbers that you get when you write the combination, the possible combinations in increasing order with 0. And since I have written all the possible combinations of 0, and the next number after 0 will be 1, right? So now you have to write the possible combinations that you get with 1 now. So now take 1 and 1. What are the basic symbols that we have in hexadecimal number system? They are 0, 1, 2, 3 and so on, right? So you just start writing the combination, possible combinations with 1. If you do so, you get what are the digits that you are going to get now? You get 1, 0. You are writing the possible combinations with 1, so please remember. So 1, and the first digit that you get in hexadecimal number system is 0. So that means you get 1, 0, 1, 1. So after 0F, these are the numbers that you get in hexadecimal number system. You get 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1A, 1B, 1C, 1D, 1E, 1F. So these are the possible combinations that you get when you write with 1. Okay, so from 1, 0, the digits are the combinations of 1 ends with 1F. But in comparison to decimal number system, hexadecimal 10 is equivalent to 16 in decimal number system. So please check it out. Okay, if I say 10 in terms of hexadecimal number, that will be equal to 16 in decimal. And if I say 11 in hexadecimal system, that means it will be equal to 17 in decimal number system. That you have to understand. This is the table which compares the decimal number systems and hexadecimal number systems. So that you have to understand here. Anyway, if I say 17 in hexadecimal number system, that will be equal to 23. And if I say 1a in hexadecimal number system, that will be equal to 26 in terms of decimal number. So that you have to understand. So anyway, it's a table which compares the decimal number system and hexadecimal number system only up to say 33. So only up to decimal 33 I have written. You can write any possible combinations. Okay, anyway, here this is 1f, right? So when you write the combinations with 1, it ends at 1f, and after that to get the next number, what you have to do, you have to write the possible combinations with 2. So that means it starts with 2 0, 2 1, 2 2, 2 3, 2 4, and it ends at 2f. So that's, you try to get it. Once 2f is end, then next the 3 0 starts and it ends at 3f, and the next 4 0 starts and it ends at 4f, and so on, it continues. Okay, so anyway, this is the table which tries to explain you a little bit how to write the hexadecimal number system logically in increasing order. I hope it is clear. Anyway, let us erase everything and just move on to our next slide. So this is a conversion of a hexadecimal number into decimal number. So how do we convert hexadecimal number into decimal number? So this is what we are going to understand in this slide. So to convert a hexadecimal number into decimal number, multiply each digit by its weight and adding the resulting products. So you already know this one. This we already have done in terms of binary numbers, conversion of binary number into decimal number. Whatever we have done, the same thing we are doing here also. So this is to understand this, let us take an example of 3a45 to the base 16. So to the base 16 means it's a hexadecimal number. It is an hexadecimal number, and our aim is to convert it into decimal number. To convert a hexadecimal number into decimal number, what you have to do, in this hexadecimal number we have 4 digits, right? 3a45. So we have to multiply each digit with their weights. You know what is weight, right? So each digit will have its own weight, which is again written in terms of its base. So anyway, the 5 weight is 16 power 0, and the 4th weight is 16 power 1, and the a weight is 16 power 2, and 3 weight is 16 power 3. What is this 16? 16 is nothing but the base of this hexadecimal number system. We already have done it, right? For example, if I this is the example that we already considered. For example, if it is a decimal number 1 2 3 to the base 10, okay, since it is a decimal number and the base of this decimal number is 10, right? So that means I can write this 123 as 1 into 10 power 2 and plus 2 into 10 power 1 and plus 3 into 10 power 0. This is how we expanded a decimal number in terms of its weight, right? Similarly, even this hexadecimal number can be expanded in terms of its weight, but its weight is written in terms of 16 because the base of this hexadecimal number is 16. Remember, this is written in terms of, in example 123, this is written in terms of 10 power 2, 10 power 1, 10, sorry, this is 10 power 0. I am extremely sorry. This is written as 3 into 10 power 0. Okay, this is written in terms of 10 powers because 10 is the base of decimal number system. Okay, similarly, let me erase this one. This is hexadecimal number system, right? And hence, since it is a hexadecimal number system, the base of this hexadecimal number system is 16, and hence the position value of each digit depends on 16. That means they can be written as the product of 16 powers. So that you try to understand. So that means The fifth 5 will have a weight of 16 power 0, and 4 will have a weight of 16 power 1, and A will have a weight of 16 power 2, and 3 will have a weight of 16 power 3. So this is what you have to understand. So this 16 power 3, 16 square, 16 power 1 and 16 power 0 are the weights of 3, A, 4, 5 respectively, and these weights are nothing but the position value of each digit, each digit of the hexadecimal number given to us. So that you have to understand. Okay, so now let us try to convert this hexadecimal number into a decimal number. Okay, to convert it, what you have to do, you already know that it is already mentioned it. You have to multiply each digit by its weight. And what is weight, I already explained here. So these are the weights: 16 cube, 16 square, 16 power 1, 16 power 0. They are the weights, and whatever the values that you get when you multiply those digits with their weights, you have to add everything. Okay, adding the resulting products will give you the decimal number. Okay, this is what we have to do. Okay, anyway, so first let us take out of 3A, 4, 5, first let us take this 5. So 5 is multiplied with 16 power 0, you know that. So this is 5. 5 is multiplied with its weight, which is 16 power 0, and the next one is 4. 4 is multiplied with its weight, which is 16 power 1, and the next one is A is multiplied with its weight, which is 16 power 2, and 3 is multiplied with its weight, which is 16 power 3. Okay, so let me erase everything now. So here coming to this one. Okay, so 3 into 16 power 3, here in place of A, what I have written? I have written as 10. You know this, right? Why? Because in case of a decimal number system and hexadecimal number system, while comparing, you already know that A is equivalent to 10. A is equivalent to 10, and hence in place of A we can write directly write it as 10, and 4 is written as it is, and 5 is written as it is. Okay, so now simplify this one. 16 power 0 is 1, and hence 1 into 5 becomes 5 into 1, and 16 power 1, which is 16, into 4 becomes 64, and 16 squares are 256. So just substitute the values, and 16 cube will be equal to 4096, and if you multiply this 4096 with 3, you will get 12288, and if you multiply 10 into 256, you get 2560, and if you multiply 16 and 4, you get 64, and 5 into 1 is 5. So these are the products of the digits and their weights. Okay, now you have to add all the products. Okay, if you add all the products, 12288 plus 2560 plus 64 plus 5 will be equal to 14917. So that means this is 14,917. So now if you convert a hexadecimal number into hexadecimal number into decimal, this will be equal to 3845 to the base 16 will be equal to 14917 to the base 10. Similarly, let us consider one more example. You can convert another hexadecimal number, which is 5B6C to the base 16 into decimal in the same manner. If you do so, what is the value that you get? You just check it. So 5B6C, so now that means each digit will have its own weight, and the weight of E is 16 power 0, it is written over there, and the weight of 6 is 16 power 1, and the weight of B is 16 power 2, and the weight of 5 is 16 cubed. So you have to multiply all the digits here with their weights. So we are multiplying it and add all the products that you get. So now E is nothing but 14. I hope you remember. So E is equivalent to how much? 14. So that means in place of E we are directly writing 14 here. So 14 into 16 power 0, and this is 6, right? 6 into 16 power 1. And what is B? The value of B in decimal number system is equal to 11. Okay, and hence in place of B we are writing 11 here. So 11 into 16 power 2 and 5 into 16 cube. So if you that means substitute the values. In place of 16 cube you get 4096, in place of 16 square you get 256, and 16 power 1 is 16, and 16 into 6 is 96, and 16 power 0 is 1, and 1 into 14 is 14. So whatever the value that you get here, you just add everything. If you add everything, it will be found, you can check it. It will be equal to 23406. So that means it's a decimal number. So a hexadecimal number can be converted into a decimal number. So this is what you have to understand. Okay, now without much delay, we just move on to our next topic. So now let us convert a decimal number into hexadecimal number. How do we convert a decimal number into hexadecimal number? This is similar to the conversion of a decimal number into binary. I hope you remember this. What we have done in case of conversion of decimal number into binary, we just use the double method, right? You remember that. This is similar to that one, but in case of the conversion of decimal into binary, we have divided with 2. We have divided the decimal number with 2, because in case of the binary, the base was 2. Similarly, since it is a hexadecimal number system, that means you want to convert a decimal into hexadecimal number system, you have to divide the decimal number system with 16 and write the remainder side by it. Okay, why we have to divide it with 16? Because 16 is the base of hexadecimal number system. So while converting from decimal to binary, you divide the decimal number with 2, because the base of binary is 2. Similarly, while converting a decimal number into hexadecimal number system, you divide it with 16, because 16 is the base of hexadecimal number. So that you have to understand. Anyway, it's simple. I hope it is clear to you. Whatever we have followed in terms of double method, that is the same thing here, but the only difference is that we are dividing it with 16. Okay, so fine. So to understand this, let us take an example here. Let us try to convert 5000 to the base 10. To the base 10 means it's a decimal number. Let us try to convert this decimal number into hexadecimal. So while converting it, what you have to do, you have to just divide this 5000 with 16 and writing the remainder side by it, and whatever the remainders that you get, you have to take it in, that means from lower side to upper side. Okay, from bottom to top. So this is the order that you have to take. Okay, anyway, so let us try to convert this decimal number into a hexadecimal number. So let us try to divide it now. So if you divide this with 16, what is the value that you get? 16 2 are 32. Okay, and then next one, 16 ones are 16 plus 3 9, and 16 3 are 48. So this is the value that you get. So when you divide this, you get 4892, and the remainder will be 5000 minus 4892 will be equal to 8. Okay, so this is, okay, sorry, 48, not 48, this is 49. 16 3 is 48 plus 1 will be 49. Okay, so 4992, and the remainder will be equal to 8. So this is what you get. And similarly, if you divide 312 with 16, you get 19 here. So 19 means what is the value that you get? You just check it. 44, and this is 30. So you get 304 here. So 312 minus 304 will be equal to 8. So you already know this. We have done it in double method. And similarly, 16 ones are 16. So that means 19 minus 16 will be equal to 3. And since this whatever the value that you get, since this one is less than 16, you can stop here itself, or else you can write this as 16 zeros are 0. That means 1 minus 0 will be equal to 1. You can write an additional step also if you want. Okay, or else you can stop here itself. So from 1 itself you have to take the order. So then now whatever the remainders that you are getting here, they are 8831, right? But these remainders have to be taken from bottom to top. This is a double method that we try to understand. So anyway, 5000 to the base 10, when converted into hexadecimal, you get 1388. 1388 to the base 16. So this is how we convert a decimal into hexadecimal. This is hexadecimal number. Since it is hexadecimal number, you are writing the base with 16. Okay, Anyway, similarly we can convert, let us take one more example, which is 2047 to the base 10. This is a decimal number. Let us try to convert this decimal number into hexadecimal. So while converting this, so the same technique that we have used here, so that have to be followed. So when 2047 is divided with 16, you get the remainder of 15 here. And similarly, when you divide 127 with 16, you get the 15 as a remainder here. You can check it out if you want, otherwise let me do this one now. Okay, what is the value that you get? Okay, 16 sevens are 112, and 16 twos are 32. 32 means plus 11 is 43. Okay, and the 16 ones are 16 plus 4 is 20, 32. So 2047 minus 2032 will be equal to 15. So this is what you have to understand. Similarly, now 16 sevens are 112. So 127 minus 112 will be equal to, again the remainder will be 15. And since this 7 is less than 16, you can stop here, otherwise you can do one more step. 16 zeros are 0, and 7 minus 0 will be 7. So these are the remainders that we are getting, and the remainders taken from bottom to top will be equivalent to the hexadecimal number system, and hence 2047 to the base 10 I can write it as 7, 15, 15. But what is 15 in terms of hexadecimal number system? You already know. Okay, so this is 15. 15 is nothing but equal to f, right? So in place of 15 we write f now. So this we have got 15 and 15, right? So in place of 15, what do we write? We write f and f. That's it. So this is how we convert a decimal number into a hexadecimal number. Okay, so fine, that's it. This topic is also over. Now let us just move on to understand how do we convert a binary number into hexadecimal number, and a hexadecimal number into binary. So anyway, in our previous topic we tried to write a table which is equivalent to decimal and hexadecimal, right? But here this is the table which tries to give the equivalent numbers of binary and hexadecimal. Remember, while converting from binary to hexa or hexa to binary, you need to remember this table. There is no other option to you. So how we started writing the binary numbers, you already know. So these are the binary numbers, right? 0 and 1. How do we use to write the numbers, binary numbers? First we take the combinations of 0, 0, and the next one 0, 1. That means we take the combinations of zeros. Once it is over, next we have written the combinations of 1, 0 and 1, 1. So 0 combinations are over and 1 combinations are also over. Next combination will be with 1, 0. So the next number will be 1, 0, 0, 1, 0, 1. And the next combinations will be 1, 1 with 1, 1. So 1, 1, 0, 1, 1, 1. And if you understand the logic, it is quite easy to write the binary numbers. Next the combinations will be 1, 0, 0 with 1, 0, 0. So you can check it. So please check it. So this is 0. Of course, for convenient I have written in terms of 4 digits, but it is not needed. This 4 zeros will be equal to 0. Okay, 3 zeros will have no value at all, and hence this is equal to 1. And what is this? This is 1, 0, and this is equal to 1, 1. And what is this? This is 1, 0, 0. Whatever the values that I have written here, the same values you are getting here. And what is this? This will be equal to 1, 0, 1. You can check it. So please check it. First you will get 0. Even here you have 0. Next is 1. Even here you have 1. And next is 1, 0. Even you have 1, 0 here. Next is 1, 1. And even you have 1, 1. And next is 1, 0, 0. And even you have 1, 0, 0. And the next is 1, 0, 1. And even you have 1, 0, 1. Next is 1, 1, 0. Can you see this one? 0, 1, 1, 0 is nothing but this is equal to 1, 1, 0. And this is what? 1, 1, 1, triple 1. And even you have triple 1. And the next combination will be what? 1, 0, 0 combinations you have read. That means 1, 0, 0 and 1, 0, 0, 1 will get it. And the next combinations are with 1, 0, 1. So 101, where is that? This one, 1010 and 1011. This is how you write the binary numbers. And when you know how to write the binary numbers in increasing order, you know how to write the hexadecimal numbers also in increasing order, right? So anyway, now this is the table which gives you the binary numbers in increasing order and equivalent hexadecimal numbers. So 0 will be, that means remember, while comparing the binary and hexadecimal number system, we try to keep it in the multiples of 4. The digits are try to keep it in multiples of 4, and that is the reason why we have written extra zeros here. That's it. But writing an extra 0 in the beginning will not change its value. Okay, so that you try to get. So 1 zeros or 2 zeros or 3 zeros or 4 zeros, that will be equal to 0, right? So check. And the next one, this is 1. Only to while comparing, I just told you, while comparing we try to keep the binary number in terms of the multiples of 4, and hence an additional 3 zeros are written over here. But this is equal to 1, and this is 1 0, right, which is equivalent to 2, but additionally 2 zeros have been kept here. And the next one, 1 1 is equivalent to 3, in addition 2 zeros are kept. That's it. Okay. And 100 is nothing but 4, 101 is nothing but 5, 110 is 6, 111 is 7, and 1000 is 8, 1001 is 9, 1010 is A, and 1011 is B, and 1100 is C, and 1101 is D, 1110 is E, and 1111 is F. So that means only up to F we have written a table which compares the binary and hexadecimal number system. But if you want, you can continue. You can write as many binary and hexadecimal numbers in this table as you want. Choice is yours. Anyway, so this table is sufficient to you for your examination point of view. Anyway, so now let us take an example to compare or convert a binary number into hexadecimal. Okay, so let us take this example to the base 2. That means it's a binary number, and I want to convert it into hexadecimal. So 101101 0111 1011 is the binary number that you want to convert into hexadecimal. As I already told you, this table you have to remember at any cost. So now 10, if I add 2 more zeros before it, it won't change, its value won't change. That is what I have done. 0010 and 1101 is written as it is, 0111 is written as it is, 1011 is also written as it is. Okay, so now you have to just compare these digits with this table. So 0010 is equivalent to 2, right? Okay, so I have written this 2, and 1101 is what? It is equivalent to D. So please check it out. 1101 is equivalent to D, and 0111, where is that 0111? This is equivalent to 7, and 1011 is equivalent to B. So you have to just compare this table with the question that has been given to you to convert it into hexadecimal. Just comparison, not more than that. So if you compare, this binary number will be equivalent to 2D7B to the base 16. That's it. This is how we convert a binary number into hexadecimal number. Okay, I hope it is clear to you. Let us take one more example. 1110 1001 and 4 ones to the base 2. We want to convert it into hexadecimal. Again, if you compare with the table, 1110 is equivalent to E, and you can check it, and 1001 is equivalent to 9, and the next 1111 is equivalent to F. Okay, so just compare and write it down. So if you compare, you get E 9F. Remember, the total digits that are given in this binary number are 12, which is the multiple of 4, and hence it is easy to compare now. Okay, so E9F becomes the hexadecimal conversion of this binary number. So 1110 1001 1111 to the base 2 is equivalent to E9F to the base 16. That you have to understand here. And similarly, let us try to convert a hexadecimal number into binary. Remember, binary to hexadecimal or hexadecimal to binary can be converted only if you remember that the table that we already discussed here. So this table plays an important role. You have to know how to write the numbers. It's not at all difficult. Just now I told you how to write the numbers. Okay. So now coming to this one. So this is how we convert a hexadecimal number into binary. So conversion of this is 7CF to the base 16, right? That means it's a hexadecimal number, and we want to convert this hexadecimal number into binary. So now take each digit. So 7CF to the base 16 I can, but that means by splitting I can write it as 7 to the base 16, C to the base 16, F to the base 16. But 7 we write it in terms of binary as, you just check this one. 7 is equivalent to 0 triple 1, and C is equivalent to 1100, and F is equivalent to 1111. So you have to just compare and write the value. 7 is equivalent to 0 triple 1, C is equivalent to 1100, and F is equivalent to 1111. So these are the conversion of 7, C and F separately into binary numbers. So if you combine and write it, 7CF to the base 16 I can write it as 0 triple 1, 1100, 4 ones to the base 2. So this is how we convert a hexadecimal number into binary number. Okay, that's it. It's not a big deal. It is very simple. You have to just remember the table that we already have written, okay, in the beginning, and that table, from that table you have to just compare the binary and hexadecimal equivalents. That's all. Now let us take one more example. Let us try to convert 2b9d to the base 16 into binary number. So as you already know, we can write this 2b9d to the base 16 separately. So 2 to the base 16, b to the base 16, 9 to the base 16, and d to the base 16. So 2 to the base 16 is nothing but, you just go to this one, not this one, yeah. 2 to the base 16 can be written as 0010 to the base 2. The equivalent binary number is this one. And similarly b, I can write it as what is b? The value of b is nothing but 1011. So write it down. So b is equal to 1011, and 9 I can write it as what is the value of 9 here? So please check it out. That is 1001. So write it down, 1001, and d is equivalent to where is d? This one, 1101. So that means 1101. So we have written. So that means if you remember that table, it's very easy to just compare and write. There is no calculation point here. So while writing the table, just use the logic and just compare. That's it. So now if you combine and write all the digits of hexadecimal number, you can write it as 2b9d to the base 16. This becomes on right hand side, whatever the binary numbers that you get, you write it down. So it becomes 0010, 1011, and the next 1001, 1101 to the base 2. So as you already know, these zeros which are written right at the beginning will have no value at all, and hence if you want to keep them as it is, you can keep it. Otherwise you just remove them. If you remove them, what do you get? You get 1011, 1001, 1101, 1101 to the base 2. So this is how we convert a hexadecimal number into binary. Okay, so these are the topics that we discussed. Anyway, so please remember this hexadecimal number system that we have covered in this video are very important and not at all difficult. So you can easily convert a hexadecimal number into decimal or decimal into hexadecimal. At the same time, you can convert hexadecimal number into binary, and a binary can be converted into hexadecimal. The only thing is that you need to remember the logic behind this conversion. That's it. Okay, so anyway, I will stop here. In our next video lesson, we will try to cover or complete the remaining topics of this chapter. Thank you once again.